Okay, my name is Arian Khan, and this is the Unit 8 interview assignment. Okay, so for the first question, we have to graph Euler's number to the power of cos x. So to graph this, what we're going to start off is by getting the x-intercepts and y-intercepts. So to get the x-intercept, you make y equals 0, which we did here, and then because your e is a constant value, whatever value you put for x, it will not equal 0. So there's no x-intercept. And for the y-intercept, we make x equals 0, and cos to the power of 0 is just 1, so e to the power of 1 is just 1. So the y-intercept is 0 and e. Now to get the max and mins, we have to get the first derivative. So we have e to the power of cos x. So we do e to the power of cos x times the derivative of cos x, which is just negative sign. And because now we have to solve for x after this part, so we make this equal 0. And because we proved here that e to the power of cos x is going to stay a constant number, we have to figure out what x will equal for this part for negative sign. So x can equal 0, pi, 2 pi, 3 pi, 4 pi, and it goes on and on, so we need a range. So when we're going to graph, we're going to have a range of 0 to 2 pi. So the x-intercepts are going to be 0, pi, and 2 pi. Or the max and mins, not the x-intercept, the max and mins. Now to prove which one's a max and which one's a min, we're going to do the first derivative test. We have these values here by subbing 0, pi, and 2 pi for x. And then we have this over here. Now we're going to create a time like this over here. And then we're going to sub in values between something that's less than 0, between 0 and pi, between pi and 2 pi, and something greater than 2 pi. So when we did this, we figured out this one's positive, and negative. So then this one, the graph is going up here, down, up, and down, which just leads this to be 0 to have a max, pi to have a min, and 2 pi to have a max as well. Now to get the point of inflections, we're going to get the second derivative of the equation. So here we're going to do product rule. We're going to do the derivative of e to the power of cos x, which is this over here, times negative sine x, which is here, plus the derivative of negative sine x, which is just negative cos x, times e to the power of cos x, which is this. Then we're going to simplify it by making these together, then taking out the e cos x, and then we're going to make it equal 0 to figure out to solve for x. Divide both sides by e to the power of cos x, and we get this, and then sine squared x minus cos x. We can use the Pythagorean theorem rule that applies here, and then we can rearrange it to make it equal like in a quadratic form. So then we can use the quadratic formula, and then a will equal -1, b will equal -1, and c will equal 1. So then that will give us what cos x equal. So then cos x equals 0.62. Now to actually solve for x, we have to do the inverse of cos, which will look like this, and then we're going to get 0.905. But then we can also use CAS rule to figure out what the other value is, which is 5.39, because the 0.90 is this angle right here, and another spot in the range of 2 pi where it will also be positive is 5.39, which is going to be here in the third quadrant. Then we can do the second derivative test here for these values, 0.905 and 5.379. Figure out which one, like find a number less than 0.9, between 0.9 and 5.3, and something bigger than 5.379. And then we got negative, positive, and negative when we plugged it into the equation, which means that this is concave down, this is concave up, and this is concave down. So we figured out the concavity. Now we can just graph it, and it will just look like this. So the graph is also in radians, and these two are the point of inflections, the max, mins, y-intercept. Yeah. Now the second question is, there's an isosceles triangle, so we know two sides are equal, and the height is changing at 3 meters per second, and we figure out what the angle is changing at, or how fast the angle is changing. So we have to figure out how fast the angle is changing when the height is square root of 3 meters. So for a relation of this triangle, we can do tan, opposite over adjacent, but SOHCAHTOA only works on right triangles, so we can just split this in half. And we know that the adjacent side will be square root of 3, and if we split this in half, this side, the opposite side will be 1. So here, tan theta divided by 2 equals opposite over adjacent, which is 1 over square root of 3. So theta should be pi over 6, and the whole thing, all the theta should actually be pi over 3, but half of it will be pi over 6. So now we can find the derivative of this to actually solve for how fast the angle is changing over time. So the derivative of tan is secant squared, and we did theta divided by 2 because of how SOHCAHTOA only works on right triangles. Then the derivative of pi over 2 is, or not pi over 2, over the derivative of theta over 2 is just 1 over 2, and then times the derivative of theta, how fast theta is changing by time, or the angle is changing by time, and then it equals, we're going to do the quotient rule here, so the derivative of how fast the opposite side is changing over time times a, and then minus how fast the height is changing over time, which is also what a is basically, times o divided by a squared, and then we can sub in values for it. So 0 because the opposite side isn't changing at all. A is always going to be square root of 3, and the height is changing at 3 meters per second, and the opposite side is always going to be 1, and then a is also square root 3. So then it becomes negative 3 over 3, and on this side we can sub in pi over 3 for theta, and over here then we can change it into 1 over cos squared pi over 3 divided by 2, because secant squared, or secant is basically 1 over cos, so there's that relationship, and then we can separate the cos, so it'd be 1 over cos pi divided by 6 times 1 over cos pi divided by 6, so then we can get into the original form. Then we can put this into our calculator and figure out what this equals, which is 4 over 3, and then multiply 4 over 3 by 1 over 2, which is 4 over 6, divide, and simplify negative 3 over 3 to negative 1, divide both sides by 4 over 6, which will just give us negative 1.5, which is how fast the angle is changing over time.